For a start, we will describe a simple way of finding the longest prefix shared by a set of string, LCP. LCP is abbreviation for longest common prefix. LCP S1 to Sn. We will use the observation. First, we compare with S1 and S2, get the longest prefix, and then this is our result, and we use this result to compare with S3 and get the longest common prefix, and blah blah blah, until we compare with Sn, get the longest common prefix, and this is the LCP from S1 to Sn. So this is the horizontal scanning algorithm. To employ this idea, the algorithm iterates through the string S1 to Sn, finding at each iteration I the longest common prefix of string LCP S1 to Si. When LCP S1 to Si is an empty string, this is an edge case, the algorithm ends and will return the empty, right? Otherwise, after n iterations, the algorithm will return the LCP from S1 to Sn. First, we take these four strings, leads, lico, lead, and leads as our example. First, we will take 5 characters because leads have a 5 character. First, leads is not equal to leak, and then we will decrement 1 character. Leads is equal to leads. So this is our first loop result, leads, and then leads. Then the second iteration, the leads is equal to leads, so it is equal, we can skip it. And then the third leads is not equal to leads, we also take the 4 character, and then because it's not equal, we can cut down 1 bit, decrement by 1, and the lead is equal to lead, so we return the lead is our result. And I should remember the pointer is from I1 to the length of strings minus 1. Let's look at another example. We have a string flower, flow, and flight. First, flower have a 6 character. Flower is not equal to flow, so we cut down 1 character to 5 character. Flow is not equal to flow, and then we cut 1 character again. So we have a flower. So we have a 4 character, flow is equal to flow. So we can skip to another iteration. This time flow only have a 4 character. So flow is, we cut the flight into 4 character. Flight is not equal to flow. So we keep going on. The flow and 3 character is not equal to fly. Then we cut 1 character again. This time FL is equal to FL, so we return FL as our final result. And so this loop will only loop 3 iterations when I is pointed at 1 or when I is pointed at 2. Let's look at another example. Strings dog, race car, and car. First, dog have a 3 character, and so we cut the race car into 3 character silence. Rec. Dog is not equal to rec, so we decrement the character into 2 characters. Do is not equal to rec, so we continue. We cut the do into 1 character D, and rec into 1 character R. D is not equal to R, so we can't keep going on. We just return the empty string, and we can skip the next iteration, skip the last element, car. Even if car have something common character with race car, we can just skip it. So let's turn the algorithm into pattern. First, we need to judge edge case. If the length of the strings is 0, the length is 0 means it is nothing. We just return empty string. And if then we can start. First, we need to declare a prefix. Prefix is our intermediate holder to hold the result. First, it will initialize to the first element of the strings, and then we can start for I in range. So I is the pointer, and it will start from the second one to the last one, the strings. So Then we need to judge whether it can run or whether it will stop. So while prefix is not equal to strings at I. Strings at I means every element we iterate, it starts from 0 to the length of prefix. So every time if the comparison one is longer than the prefix, it will be cut off to have the same length of the prefix. And then every time prefix will decrement by 1. So if it don't find, it will decrement by 1 until it find from the first element to the length of prefix -1. And another case is if we don't find after main loop, we don't find it, we just print it out. Because every time it is cut, it is cut 1 unit bit by bit. So if it don't find anything, it will remain nothing. If it remain nothing, we just return empty string. And finally, we will get the result. It whether empty or the prefix have something remain, we can return. Yeah, we get it. Let's analyze the complexity. The time complexity is O of S, where S is the sum of all characters in all strings. In the worst case, all n strings are the same, so the character compares the strings S1 with the other strings from S2 to Sn, and their S character comparison, where S is the sum of all characters in the input array, and the space complexity is O of 1. We only used constant extra space. Imagine a very short string is the common prefix at the end of an array. The above approach will still do S comparison. So another way algorithm to optimize this case is to do vertical scanning. In one string, the same character index is a one column. So on the same column, we compare characters from top to bottom before we move on to the next column. Let's analyze its complexity. The time complexity is O of S, where S is the sum of all characters in all strings. In the worst case, there will be n equal string with length n, and the algorithm performs S is n multiply n character comparison. Even though the worst case is still the same as approach 1, well, in the best case, there will be almost n multiply minimum length comparison, where minimum length is the length of the shortest string in the array, and the space complexity is O of 1 because we only use constant extra space. So let's take the flower, furrow, and the flight as our example to show how to build the algorithm. First, we draw a opposite J and I to these two pointer. J is represent the row. Row is the how many words in the strings, and I is another pointer to track every character in the word. So let's start. F equal to F, F equal to F, so we record F. L equal to L, L equal to L, so we record L. O equal to O, O is not equal to I, so we finish and return the last I section until, so it is FL. So this situation we can judge statement, string J at I is not equal to C, we finished. And another situation is when the I is reach the last element of this word, we also finish and return. So let's try to implement the algorithm in Python. First, we need to consider the edge case. If the length of the strings is 0, means there's no element inside it. We just return an empty string. Right, then we can start. First, we set an outside loop for I pointer in the range. So this pointer is around the first character of the string. So it is the length of the first character, the index 0. So inside it, we need to declare a cs for character inside the first word's strings. 0 means this is the first character pointer at I. So C is for character. We iterate every character in the first word, and then we can say J is for around the whole string in the range from the second word to the last word length of string. So if the I is equal to the length of the strings J, that means we reach the end. We reach the end of the string, right? We reach the end of these words, so we can stop and return all the strings at J at I is not equal to C. That means we can also continue. We can also return because they are not equal. The character and words is not equal. Like this, we just return the strings 0 and silence the first to cut into size, and then we return the strings, the first character, the first word. So that is how it works.